Good morning students and welcome to our third virtual class. I hope you have gone through the previous videos and done your worksheets as well. So let's begin with our today's topic, that is the change of state. What do you mean by the change of state? We know that matter exists in three states, that is solid, liquid and gas. Now the process of change from one state to another state, either by absorption or by rejection of heat at fixed temperature. This thing will happen only at the fixed temperature. So these are the key words there. Either by absorption or rejection of heat at a fixed temperature or constant temperature is known as the change of state. Now we will study the change of state from one state to another one by one. So solid to liquid, liquid to gas, gas to solid, one by one. So first we will start with the first conversion, that is from solid state to liquid state. So first is from solid to liquid. Whenever solid converts into liquid state by absorption of heat at fixed temperature, the process is known as melting or fusion. One and the same thing. So the process is known as the melting and fusion, but the temperature at which this happens, that fixed temperature, that temperature is called as its what? Melting point. That fixed temperature is known as its melting point. For example, ice at 0 degrees Celsius converts into water at 0 degrees Celsius. Both are happening at the same temperature, that is 0 degree. By what? By absorption of heat. At which temperature? At 0 degree temperature. So for better understanding, we will perform an activity with the arrangement as shown on your screen, in which we have taken wax in a test tube with thermometer is kept in a water beaker over the flame. Now we will measure the temperature of the wax after every single minute and note down the things. You will observe that the wax melts at 55 degrees Celsius with the regular supply of heat, as you can see in the data given on your screen. But there is no rise in the temperature. Thus, the melting point of wax is going to be 55 degrees Celsius. After melting of the whole wax, the temperature begins to rise. You can see in the data given on your screen. So this is all about the melting or the fusion. The next is the reverse process of this. That is when liquid converts into solid state. When liquid converts into solid state, what will happen? Now we are moving from liquid to solid. That is from water to ice. For an example, this process in which the liquid converts into solid by rejection of heat at fixed temperature. What is the temperature? 0 degrees Celsius. The process is known as freezing. The process is known as freezing. And the temperature at which this happens, that temperature is called its freezing point. For the better understanding, we can continue the previous activity but in the reverse order. So what we will do, we will notice that the wax freezes again at 55 degrees Celsius. After the complete wax has frozen, then only the temperature begins to fall again, as you can see in the data given on your screen. Now both the things are happening at the same temperature. Both the things are happening at the same temperature with a continuous supply of heat. Now where does this heat goes? As the things are happening at the same temperature. So where does the heat go? Now with the continuous supply of heat, either by absorption of heat or by rejection of heat, things are happening there. If we will take the melting case, let us understand where does this heat goes. Let us take the case of melting. Now what will happen in the melting? It will solid converts into liquid. Now what is the molecular structure of the solid? They are tightly packed, so there is no much space to move around. Molecules does not have space to move. So the vibration or the motion of the molecule in case of solid is like they are vibrating about their mean position. They are just vibrating about their mean position. Intermolecular spacing in case of solid is very less, but intermolecular spacing in case of liquid is large as comparative to solid. So it means when we are going to convert solid to liquid state, we have to increase the space. It means to increase the space, we have to break the intermolecular forces of attraction. It means we need to overcome the forces of attraction there. So if we are going to break forces of attraction and increase the spacing between molecules, then only the solid converts into liquid state. So if the molecules are in vibration mode, it means they are moving to and fro about their mean position. It means they possesses kinetic energy. They have some kinetic energy. That's why they are moving about their mean position. Now what will happen with the continuous supply of energy or heat? Continuous supply of heat. What will happen to this motion? The motion of the molecule is going to be violent. It means their kinetic energy is going to increase. There is increase in the kinetic energy. Again with the continuous supply of heat, they got so much, molecules got, they will get enough of kinetic energy to overcome what? Forces of attraction. Or to break the bond between the molecules, and then the solid converts into the liquid state. This is according to the molecular model of the solids. Now in change of state, so if there is a change in the state, what will happen? It means we are decreasing the forces of attraction, increasing the intermolecular spacing. It means the potential energy is going to increase. Potential energy is going to increase there. Increases. Alright. Now, in change of state at fixed temperature, just to note down the things as I have written on the board, you can pause the video. Now, in change of state at what? At fixed temperature, the amount of heat, the change can be from solid to liquid or liquid to solid. The amount of heat taken to or sorry given to or taken from. This is melting and this is freezing. Taken from the substance does not cause a change in temperature. As we have seen in the activity, this heat with which there is no rise in the temperature, that heat is called latent heat, or you can call it as hidden heat. Why it is called as hidden heat? Because it is not manifested by any change in temperature of the substance. And when we will measure that heat, if that heat is measured for a unit mass, this latent heat we can measure for any amount of mass, but if we will measure the heat, that heat for a unit mass, then it is called as specific latent heat. Why specific? Now it is specifically measured for the unit mass. That's why it is called as specific latent heat. As we are measuring it for a specific unit mass, so its SI unit is going to be joule per kg. SI unit is joule per kg because we are measuring it for a unit mass. Now we have to note down few points, or you can say the conclusions regarding the water, ice. So the points are: water expands on freezing. Generally this is the reverse of the case for other substances. Other substances will contract on freezing, but water expands on freezing. Why? Because of its anomalous behavior. And what is this behavior? It means water is going to contract on providing heat from 0 degree to 4 degree Celsius. After reaching the 4 degree Celsius, it behaves normally. That is, it is going to expand on providing heat. Now the melting point of ice decreases with increase in pressure. But melting point of wax is going to increase with increase in pressure. Third, melting point of ice decreases when salt is added. It means with the addition of impurity you can decrease the melting point of ice. So this mixture is known as called freezing mixture. And the mixture is going to be used in preparation of the ice creams and kulfis. Thank you so much.